Hello and welcome to today's webcast brought to you by Power Grid International Magazine. Today's event, Innovation with Energy and Utilities at Amazon Web Services, is being sponsored today by Amazon. I'm Rod Walton, Senior Editor of Power Grid International, and I'll be your moderator for today's webcast. Before we begin, I need to cover a few housekeeping items. At the bottom of your audience console are multiple application widgets for you to use. They are pretty self-explanatory, but I do want to point out the question and answer tab. If you have any questions for our speakers during the webcast, you can click on the Q&A widget and submit your questions. Our speakers will answer the questions after they completed the presentations, but you can type in your questions at any time during the webcast. You may expand the slide area by clicking on the maximize icon on the top right of the slide area or by dragging the bottom right corner to enlarge it. In fact, you can expand and reposition many of the components on your screen, so please feel free to arrange them any way you'd like to give you the optimal webcast viewing experience. If you have any technical difficulty during the webcast, please click on the Help widget. It has a question mark icon and addresses common technical issues. If you still need assistance, just type your question into the Q&A widget, and a member of our webcast support team will work with you to correct the problem. For your convenience, this presentation will be available on demand within 24 hours of this event. A reminder email message will be sent to all registrants with a link to the archives. It will also be accessible from the magazine's homepage at power-grid.com. So if you want to go back and view all or part of it later, or you want to encourage your coworkers to view it, it will be available for 1 year. In addition, a PDF of the presentation is available for you to download. You can find it in the Event Resources area of your console. Now, I'm happy to get to the part where I can introduce today's speakers. We have Rolf Gibbles and John Nichols. Rolf Gibbles is Worldwide Head of Business Development for Power and Utilities at Amazon Web Services. John Nichols is Director of Enterprise Architecture at Pacific Gas and Electric. John is the Director at Pacific Gas and Electric in the Enterprise Architecture and Digital Innovation team. He leads the cloud strategy along with the R&D for IT. John has over 25 years of experience in IT across utility, financial services, and winery industries. His journey in the cloud started in 2007 with Amazon Web Services. John has 2 AWS professional certifications. John uses that knowledge to lead digital innovation at PG&E as well as educate others about the cloud. And now I'm going to turn it over to Rolf and John.
Wonderful. Thanks, Rod. Thanks for the introduction. Yeah, good morning, good afternoon, everybody. I'm actually here together with John in San Francisco. We're really looking forward to this good 60-minute session together with you. We'll walk you through various topics from an AWS perspective in power and utilities as well, obviously, mainly John's view and journey through the cloud journey with AWS and at PG&E, and we followed up with the Q&A. I would like to start the first part of this webinar with a quote from Jeff Bezos, our CEO. Invention comes in many forms and at many scales. The most radical and transformative of inventions are often those that empower others to unleash their creativity and to pursue their dreams. This is really a motto we use every single day in our work at Amazon, and this quote really demonstrates how Amazon thinks about fostering innovation for others. This can be teams within Amazon, but then more importantly, developers, businesses, and enterprises outside of Amazon, so like companies John works for, like PG&E. One of the central areas of innovation for Amazon Web Services can be in the speed and depth of new services and features. In 2011, we just released over 80. In 2016, we launched over 1,000 new services and features, and consistently growing this portfolio, which reached in 2017 way over 1,400 of new features and services. And all along this growth of new services and features, AWS has reduced prices 65 times since AWS launched in 2006. So AWS offers a broad set of global cloud-based products. It includes products from compute, storage, databases, analytics, networking, mobile, developer tools, management tools, IoT, security, enterprise applications, as you see in this image here on the slide. The service helps organizations move faster, lower IT costs, and scale. AWS today is trusted by very large organizations, enterprises, the hottest startups like many here in San Francisco, to power a wide variety of workloads, including web and mobile applications, game development, data processing, warehousing, storage, archive, and many others. So customers today reach from the Netflix of the world, Dow Jones, GE, to various government agencies and thousands of startups such as Airbnb and Lyft here in the Bay Area. The broad set of solutions, its affordability and agility are the core reasons that cloud has become the new normal, as companies of every size are now deploying new applications to the cloud by default and looking to migrate as many of their existing applications as they can and as quickly as possible. So for enterprises, the question isn't really if anymore, it's really just how fast can we move and where can we going to move first. So with that, let's talk about our industry we're here for. So I'm going to briefly give you an insight on the work we're doing in power and utilities as AWS. And then again, John, you will learn from John further about his work. And I will give you a quick insight on how you actually can get started on the topic today. Utilities are going through tremendous change. I think you're all on the call right in the midst of it. For decades, electricity was supplied in simple, hierarchical structure with a very few energy sources, mainly hydro, fossil, and nuclear energy. And a vast transmission and distribution network supported the consumers, who often were mainly referred to as load and not as customers. For the past several years, we have seen a dramatic change. We have seen the rise of a flat structure, adding new renewable energy sources such as wind, solar, battery storage, rooftop solar, and new loads such as electric vehicles. Energy creation is moving close to the consumers, and the consumers creating their own energy. So the dynamics have completely flipped. Instead of focusing on how to increase electricity production, plan for large capex investments over power plants of major transmission lines, it's evolving towards consumer-focused, consumer-driven initiatives related to energy conservation, energy prosumers, and more decentralized systems. So the 3Ds are a good way to kind of summarize those core trends: digitization, decentralization, and decarbonization. Digitization is taking place everywhere. We have a growing number of sensors constantly measuring things like temperature, pressure, humidity, wind speeds. But today, still only 2-3% of this data is really effectively being used and analyzed. We have an explosion of IoT devices in our homes and buildings, and industrial IoT on wind farms, power plants, and along the grid, including smart metering. With decentralization, as I mentioned earlier, we see more and more generation and new loads very close at the place of consumption, again driven by rooftop solar, more and more battery storage, EV cars coming in as new loads, hence turning consumers into prosumers and creating the opportunity to feed back energy into the grid. So from an AWS perspective, how do we realize with AWS and what benefits are we bringing? And I'm listing here 4 of those benefits. Achieve operational efficiency and excellence. AWS provides elastic, cost-effective compute and storage capacity so you can quickly provision resources to run demanding high-performance workloads like demand response and weather forecasting. Security is always on top of our minds. So with AWS, you can take advantage of a scalable, reliable, and secure global computing infrastructure that also powers Amazon.com. In the time to reduce time to business insights, really leverages comprehensive breadth of latest analytics tools, IoT, machine learning, artificial intelligence, to further harmonize large volumes of data to fuel insights and innovation around how energy is generated, provisioned, and consumed. And lastly, build innovative applications, which you will hear a few cool things from John in a little bit. AWS provides a development platform to rapidly develop innovative solutions such as to detect and service outages or to help consumers manage energy usage. ENGIE is one of those examples who is already very far along in their cloud journey, and I can comfortably say they have applied all of those 4 areas I just mentioned. ENGIE is a global power and gas company. They have over 150,000 employees. They're almost 200 years old, so quite a bit around in this business. And they're implementing an ambitious digital transformation strategy that is vital to its plan to be at the forefront of an energy sector that is undergoing those revolutionary changes. They actually have a $1.5 billion digital transformation investment, which they're applying over the next 3 years, and includes the digital development of a global center of excellence, a COE, which is targeted to have over 100 people, skilled scientists, developers, business analysts from ENGIE, but also from our partner C3 IoT in this case. The CEO is responsible for developing and deploying 28 next-generation machine learning applications, and they're going to reach around fraud detection, customer relationship management, sensor network health, and various SaaS applications ENGIE is developing with our partner. Enel is one of our flagship accounts, which has done a tremendous change in the way they're going about the business. Enel is actually one of the Fortune number 5 companies capable of changing the world. Enel uses data-driven analysis of energy consumption in real time to distribute energy more efficiently. Enel is migrating 75% of its infrastructure to the cloud in support of its open power vision to make energy more reliable, efficient, and sustainable. Between September 2015 and April 2016, over 6,000 servers were migrated to AWS. So a tremendous effort and accomplishment here by Enel. And benefits realized are up to 50% savings on storage through right sizing, 20% savings on computational power due to reserved instances and downsizing, and the provisioning lead time has improved from 3 to 4 weeks to 2 days, to only 2 days. This is still just the beginning for Enel on their cloud journey. The initial work is the foundation towards many innovative projects they're undergoing related to IoT, the smart grid, and as well as the connected home. And yes, security will always be our top priority. Examining the AWS cloud, you'll see that the same security isolations are employed as would be found in traditional data centers. These include physical data center security, separation of the network, isolation of the server hardware, and isolation of storage. An important also is that we have a shared responsibility model with the customer. AWS manages and controls the components from the host operating system and virtualization layer down to the physical security of the facilities in which the services operate. And AWS customers are responsible in return for building secure applications. In addition, AWS partners offer hundreds of tools and features to help customers to meet their security objectives, ranging from network security, configuration management, access control, and data encryption. The Talen Corporation is one of the largest competitive energy and power generation companies in North America. Its primary business is the production and sale of electricity in competitive wholesale power markets. An AWS partner, Accenture in this case, engaged with Talen Energy in 2016, and Accenture provides operations and technology services with an infrastructure as a service model for business application hosted in a virtual cloud on Amazon Web Services. So Talen Energy runs this nuclear power plant and ultimately needed to find a provider that would meet its technical needs and also those of the NRC and NERC. This relationship with AWS serves as a good example how companies with complicated regulatory requirements are finding solutions in the cloud. Part of Talen Energy's decision to go with AWS was because they could meet the appropriate 10 CFR 810 requirements for a subset of Talen Energy applications through the dedicated AWS GovCloud, government cloud. The Internet of Things, it's actually, I don't know if everybody knows, but I looked this up over the weekend, is coined by Kevin Ashton, a British technology pioneer working on radio frequency identification, so the RFID tags, I think most of us know, and who conceived a system of ubiquitous sensors connecting the physical world to the internet. So all those things, internet and connectivity, are the three core components of IoT. The value is in closing the gap between the physical and digital world in self-reinforcing and self-improving systems. If you knew the state of everything in the world and you can reason on top of the data, what problems would you solve? Obviously, a very interesting fundamental question. To help you answer that question and extract the value from your connected devices, AWS has built IoT-specific services such as AWS Greengrass and AWS IoT Core. They help you collect and send data to the cloud, make it easy to load and analyze that information, and provide the ability to manage your devices so you can focus on developing applications that fit your needs. Very important message. Here's one of my favorite slides. How often have you been in this situation? Innovation is in our Amazon DNA, and our structure and approach to product development delivery is fundamentally different than other IT vendors. One example is that at AWS we hire builders. And we think of builders as both people who like to look at customer experiences, figure out the pain points, and reinvent them. So what we often see with our customers, that if you have a great idea, you get immediately turned down due to cost and resources. AWS Cloud changes this dynamic completely. While having a lower cost infrastructure is an enabler for transformation, it's typically not the main driver. The main drivers are agility and innovation, and the cloud enables these in a very significant way. In the old world, when you ask engineering teams how long it might take them to get a server to try an experiment, you get an answer like, maybe 10 to 18 weeks. In today's cloud world, not only can a company spin up thousands of servers in minutes and pay only what they use, but they have access to a very robust, full-feature technology offering that lets them go from idea to launch in record time. Here, I just want to highlight Centricity as one last example, who is a builder in the UK. They are around Bord Gas and British Gas. They have offices or representation in the public island and also North America with Direct Energy. They have over 18 million residential customers and 800,000 business sites in the UK they manage. Brands including British Gas and Bord Gas, as well as Hive. And Hive is Centricity's product, which has a comprehensive strategy around connected home, including their own set of IoT devices. And Hive is actually leading thermostat in the UK, and the portfolio of smart home devices is rapidly growing, including the voice enablement through Alexa. So Centricity can now experiment very cost effectively while paying only for resources consumed. With that, I just want to give you another list of companies and partners we're working with. It's a very deep group of customers and partners which are really essential to growing the adoption of cloud in the power and utility space. Before I hand it over to John, I would like to just share 4 quick use cases from connected home to also how critical business applications like SAP is being used. The connected home is becoming more and more reality for consumers. Customers can buy Alexa, smart home devices, and consultation via Amazon.com. Amazon consultants can come for on-site consultation and installation in your house and small medium businesses. Alexa can help customers manage energy usage, and the connected home helps build utilities to manage more efficiently and holistically their consumer energy consumption and overall demand response. This new form of interaction with customers can help provide a lot more timely information. For example, the air filter or Freon needs replacement, or you can easily schedule a service engineer to reduce costs and maximize your air conditions efficiency. Intel is a partner in this journey for AWS to provide core technology for gateways and other edge IoT devices to realize this offering. And recently we announced a partnership with Lennar Homes. Lennar, one of the nation's largest builders, announced the world's first Wi-Fi certified home designs featuring an integrated home and automation system, voice controlled with Amazon Alexa. Here's an example of a very important tool and application or service we are providing. The AWS Industrial Time Series Data Connector is available via Quick Start, actually on aws.amazon.com. The Quick Start deploys the AWS Industrial Time Series Data Connector on the AWS cloud. It synchronizes your OSI Pi system data to AWS to enable advanced analytics on your industrial processes time series data. Now you can deploy the connector from your own AWS account in less than an hour. After deployment, you can establish near real-time managed feeds for selected data, get your data to Amazon Simple Storage Service, or Amazon S3, keep it current, and explore and analyze your data with AWS analytics services such as Amazon Elasticsearch with Kibana and Amazon Kinesis. This Quick Start was developed by 47 Lining in collaboration with us, with AWS, and 47 Lining is an AWS competency partner. EDF Today, for example, uses this connector to migrate historian data to AWS to enable more innovative AI, machine learning type scenarios. Amazon Connect for power and utilities. Amazon Connect is a self-service cloud-based contact center service that makes it easy for any business to deliver better customer service at lower cost. So Amazon Connect is based on the same contact center technology used by Amazon customer service associates around the world to power millions of customers' conversations. The self-service graphical interface in Amazon Connect makes it easy for non-technical users to design contact flows, manage agents, and track performance metrics. So no specialized skills are required. There are no upfront payments or long-term commitments and no infrastructure to manage Amazon Connect. So various studies actually have shown that the majority of utility customers are willing to forego the call center completely if provided an ideal online experience. So millions could be saved here by reducing call center volume. A very interesting topic. And just to further increase the volume, the value, on Amazon Connect, Cognitive Care is one of those tools which can field thousands of questions pooled across multiple companies, which then can be shared and utilized in a single platform offered from partners like Wisdom.ai, for example. A question now could be, show me how to set up my thermostat. So beyond simple questions like PG&E, what is my power bill? This connects you to a call center rep to help, and if they can't resolve it, we'll schedule a callback for a call center representative. Then a text message follow-up is created for rating your experience, so constantly looking at improving and increasing the customer excellence for the utilities. The last example I just want to give is on the business layer. There's many of those around the business, various business applications. SAP Business Intelligence Analytics introduced the SAP BW for HANA, and the agility and that together with the agility of the AWS platform introduces a number of specific customer benefits. So I just want to mention too, there's the increased speed. So never before could customers initiate a mission-critical, very large SAP environment in under 1 hour. So taking the complexity out of the infrastructure considerations, customers can start exploring the for HANA immediately, and one doesn't have to be right the first time. So the BW for HANA environments are running on AWS X1, so X1, the instances, as they are part of Amazon EC2. And it's memorized, it's in the EC2 memory and optimized instance family. It can grow but reduce in shorter time, so further reducing the risk of overpaying for those IT infrastructures. And obviously you can innovate much, much faster. So with the speed that we're introducing comes the ability to try faster, more holistically, adding new cloud environments, upgrading it to the latest SAP version, and exploring the new functionality has been greatly, greatly simplified. And cost, obviously, is always a topic. So with that, I just want to finish last quote from Jeff Bezos, and then I'm going to hand it over to John. We had 3 big ideas at Amazon where we have stuck with for 20 plus years, and they're the reason we are successful. Put the customer first, invent, and be patient. And this is always my message when I meet with utility customers, I think it's very important to look at your customer, and also things take time. So patience is critical. If you look at the first Kindle out there, that wasn't a very impressive product, and now we have a lightweight version of this Kindle, which is used by millions of people. So with that, I would like to hand it over to John Nichols. Go from here.
All right. Thank you. Thank you very much for that. And as always, Amazon continues to innovate at paces that just are mind-boggling. If you don't keep up with the weekly emails, you're behind. It's astonishing. So I'm here to talk about 3 topics today. The first one is what is driving PG&E to adopt the cloud. The next are a handful of use cases, and then I'm going to end up with how we're preparing for that and how we're making the big transformation. So what are the big reasons for PG&E to be embracing the cloud? We're, as Rolf mentioned earlier, we're under industry disruption. So right now, we have to be affordable. For the first time in over 100 years, the growth of our product, energy, the consumption growth, is flattened. And as a result of that, we have to find ways to take cost out. At the same time, at the edge of the network, the grid network this time, we're being disrupted. The utility industry as a whole is being disrupted because of the invent of renewables. Not just the invent of renewables, but what renewables do to the grid itself, and the variability of power that's generated by renewables creates a need for us to balance the grid in different ways. Also, we're now in, at least California, we have embraced this concept that the wildfires and the natural disasters that occur, those are now, we're considering them the new normal. And so we have to prepare ourselves to respond to any of those disasters much faster, look for signals in the field so that we are more prepared about what's happening there. One of the examples is we're looking at if we can detect wildfires or some other kind of thing in the field, can we automatically shut down power to that feeder so that we prevent fires caused by down power lines. One of the big things that we looked at when we first started was, well, which cloud provider do we want to go with? When we realized this, we looked at, when it comes to affordability, the cloud providers today are able to run their data centers at a scale and efficiency that most companies cannot reach. It's astonishing at the level of amazing innovation that's happening inside Amazon and the other cloud providers. And when we looked at that, we said, well, do we want to continue investing in running our data centers, or do we want to embrace what they can do for us? And we decided that, yeah, we absolutely want to go there because the speed to market, the agility, and the innovation that we get to take advantage of. So we looked at AWS very early on, and we said, look, they're industry leaders. They have all the best security things, and they've been out in front of this for a lot longer than the other cloud providers. And lastly, one thing we did earlier this year was say, we're just going to focus on AWS and enabling AWS. And my whole premise in making that decision was we need to get good at a single cloud platform before we actually branch out and look at multiple clouds. And this was a big decision because we were on the path to enabling multiple clouds, and it was going to take us another year to actually make that migration. And I said we must just focus on one so that we understand what it means to operate in the cloud, because it is a mindset shift. It's not like operating your data centers that you have today. And I'll talk more about how we're embracing that mindset shift in the coming slides. So I have 3 use cases that I'm going to cover. We have a simple web app that we've done. We have some analytics and some computer vision elements that we've been able to prototype and invent with. And then finally, so what we're preparing to do with our data center migration. I'm going to start with the web app. And so the use case here is PG&E has recently, just winding the clock back a little bit, PG&E has recently, in the last year, embraced user-centric design. And this is where we bring in the actual users of the applications and we work together with them side by side in an agile format, designing screens and workflows and experiences that make their jobs much easier. So we're absolutely focused on the end user customer in this case. In many cases, it's the people doing dispatch, people putting together construction packages, those actually doing the work in the field, collecting, inspecting data. And in this case, we have the idea of work getting scheduled for crews. We have a very simple web app that was built. And what happened was, over the last, this is very recent, the last few months, that team, that development team, was working with the Cloud Center of Excellence, and they simply said, if we could just host a static website in S3, we could do so much. And it turns out that our own internal interpretation of policies made it very difficult to do that. And what was happening here, as soon as in AWS land, there's just a simple click a couple of buttons and make a few changes, and you can host a website in S3 in their storage platform. And it's really easy. So it's like, well, why is that preventing us? Well, as soon as you say host a website, that bucket, that S3 bucket, becomes public. And any of you who've been following the news about security breaches, you know that that's not a good thing in often cases, especially if you've got sensitive data in these S3 buckets. So there was very much we shouldn't do that. And what I ended up doing was pulling together a dynamic team of cross-functional people from our security team, people from our development team, people from our cloud team, and working with them 7 by 24 almost. It was 6 to 8 hours a day in a room working on this one use case. It took us about a week to do. And you would think, I could click a button, I can make it happen. Well, what about when we think about the different requirements, one of the main requirements was we want to make sure that that website is only available to people with devices connected to the company network. And there's ways to do that with AWS, and they're native to AWS. And one of the big ones, so we're using Web Application Firewall to whitelist our IP addresses so that only IP addresses from our corporate network can get to these websites. We're using the content distribution network solution called CloudFront to encrypt the traffic end-to-end. And we're also using the code pipeline feature from AWS to do a CI/CD pipeline build. So when our developers check their code in to GitHub, it triggers a build that AWS picks up, does its thing, and then pushes the updates into the website. And so it's this end-to-end automation. So now we can push changes in minutes rather than hours or days. One of the big things that to do on this is to work with our change management team to make sure that all of the requirements for registering these changes are met so that the automation can take place. This pattern of having an external endpoint exposed and then secured so that only PG&E data or PG&E systems can access it is a common pattern for a lot of the AWS services, including things like the API gateway and Lambda. Lambda's serverless environment is just astonishing. We're really looking forward to taking advantage of that capability. So we will continue to do this work with these different services. In fact, this week and next week, in real time here, we are looking to enable the API gateway and Lambda. I'm going to move on to another use case that we've got with our analytics team. And the setup for this is we have engineers in the field that are using multimeters and various measurement capabilities. In this case, they're measuring the corrosion on our pipes for the gas pipelines. And this is very important because we've got to make sure that we don't take, the electricity isn't able to traverse the pipelines. There's a lot of technology stuff here that technical stuff that I don't understand, other than they say don't let that happen. And so what's happening today is these engineers are out in the field and they're taking readings and they're writing them down on pieces of paper and they're bringing them back and keying in those entries. And so they're having to touch the data and this information multiple times. And what we decided was, well, if we could take the multimeter reading, use an app on our phone and take a picture of the reading and have it capture very reliably the readings and have that captured in the system and sent back, then we end up with you only see it once. You only look once, which is YOLO, which is is very much a user-centric design thing. Only want to have to look at this information once and have confidence that it's going to get into the system. So the team, our analytics team, started working on this. We have a great group of data scientists who have been working on AI and computer vision. And they had spent some time building a platform up so that the data was available and they could mock things up and they could spin up Amazon resources very quickly. And what happened here was what would have taken and we have a use case from last year where we stood up a Spark cluster, which is an analytics platform. It took us a good 4 or 5 months to do that. It took a really extended period of time, and we had to have a bunch of servers built for us to do that. Well, if we took that exact scenario, it would have taken us 4 or 5 months, and when we calculated it to be about $30,000 to stand up these servers, we did it in a day with Amazon, and it took us less than $25 to run these simulations. And so this is a great example of the speed and agility that Amazon provides us as a company. There's a lot more to do here because this is very much in prototype land. We're working on packaging it so that the data that we're capturing, the sensitive data, can be stored in Amazon to the highest levels of sensitivity, and so that we will productionalize this application and roll it out to the field engineers. We have great ways this is wonderful. Some of our leadership got to see this in action recently, and it went over really well. So great use case and a wonderful example of how the power of Amazon comes to bear. And the other thing I'll just say about this was really powered by what's called the GPUs, the GPU instances in Amazon. GPU, graphical processing unit, GPUs, allows for massive multi-parallel processing to happen, and it's one of the things that powers machine learning and AI, artificial intelligence. And because of that having it available, if you were to do this same simulation with traditional CPUs, it would take 1,000 hours or something ridiculous just to find one of these images on the multimeter. Be able to read one set of numbers off. With this, it happens in seconds, or less than seconds. So it's astonishing. Again, having all these different tools available. The last thing I'm going to talk about is our cloud migration strategy. So we're now launching the second half of 2018. We're really going to go hard at the migration of some of our existing workloads. We're not going to go big with that. We're going to go figure out what it's going to take us this year, and starting next year and in 2018, then we'll look to scale that capability of migrating our applications. And what I have on the screen here is a workflow that we use. We have over 1,000 applications, and many of these have different levels of sensitivity. I will say here that we aren't looking to migrate any of our operational systems to the cloud anytime soon. Anything that's SCADA related or actually operates the grid will remain on-prem and in a separate network. So those are some security things that we as critical infrastructure are looking at. We did just finish a cloud readiness assessment with AWS. And out of that is coming an action plan, and we will look to do a pilot where we take 5 to 6 applications that are part of our data center migration. We've got multiple data centers, and a few of them we're looking to shut down to save money, and out of that we were looking to pull 5 or 6 applications and run a pilot on. In this decision tree at a very high level, the very first decision that we're looking at, whether it's running our AIX platform or our Intel platform, can we archive this system or this application? And if we can, that's wonderful. And one of the beautiful things here is the data that is available, that's on those systems, if it needs to be available for longer than the system needs, if it needs to be around for whatever purpose, we're going to look at the Amazon native tools, S3, for example. You can now load data into S3 and using various tools there, query that data using natural SQL or SQL queries. It's called Athena. So that's one thing we're going to look to do there. We'll also look at if we can package this into either AWS and AMI or into a container and put it up there into the cloud and have it available if the application is required to read the data. We're going to look at, can we do that so that we can launch the application only when we need it? Like, those applications that run once a year, and we can't, we're spending lots of money keeping that application alive and patching it and all the things that go along with that for one time a year. So we're looking at different ways to make that real. If we can't archive it, we're going to look at, can we refactor it? Or can we lift it, tinker on it, and then shift it to the cloud? Now, refactoring there's a lot to refactoring. So if you're going to re-architect it or change it, there's got to be a decision that says, is that worth it? So if there's an application that's going through a lot of changes, then we would look to refactor it. If it's one that's not changing very frequently, then we'll look at, can we lift it and then tinker on it and then shift it to the cloud? And really what tinkering means is, let's say it's running a database. Well, is that database available from AWS as a managed service with their RDS solution? So we'd look at that first. If that's not possible, and this is, if you're looking at the workflow here, this is the C indicator, the containerize. Can this application be containerized? So can we use things like Docker to package this application up? Because if we can, then we can actually migrate that to the cloud using using cloud services that are available from Amazon and others like Kubernetes. So that's our last step in this. And if that can't happen for whatever reason, if it's running a very old operating system or something along those lines, then we would actually migrate it to our new internal cloud that we've got in our new data centers, relatively new data centers. Now, one of the things that we're concerned about here is, it would be very easy to continue on the path of just migrating our things. We know how to operate our internal data centers fairly well. It would be easy just to continue to do that. But what we realized is there's a mindset shift that comes along with making the jump to the cloud, and we want to get prepared for that. And what we did to put that in place is create something called the Cloud Mentorship Program. The history here is a small group of us went through the process of really understanding the cloud a few years ago. And we realized that there was a point in time on that journey where the mindset shift just made all the difference in the world. It was no longer worrying about that pet of a server that had a name that I had to care and feed. It was, I can very quickly spin up an entire application platform at the click of a button, and if I need to, I can shut that down or shut servers down and do all those kinds of things. And the minimum effective dosage to making that shift is, for us, was becoming certified AWS solution architects at the associate level. And there's a premise that says if you can have 10% of your workforce operating in the new way, you hit a tipping point. And so I have a personal goal to get just over 100 people certified in AWS over the next year to 2 years. And as part of that, we put together this Cloud Mentorship Program. And we're looking at, can we not have to invite a lot of third-party system integrators to do the work for us? Can we make it part of our work? So this is very successful. We have over 170 people signed up as part of this mentorship program. We've got close to 20 people certified now. We're well on our way to making that my personal goal. To make that even more interesting, we built an app that lets people sign up and manage their certifications. It helps the mentors work with the mentees, the participants, assign them work, send out emails. We built this app all using AWS services. There's no servers involved at all, so it's all serverless. We did this, it took the team that was working on this, had been working very cloud-centric for just about a year. It took them 4 days to create the minimum viable version of this, which was astonishing. And it was, one afternoon they knocked out most of the work, and then over the next several days they polished it. And we have a whole backlog of work that as the mentees, the participants in the Cloud Mentorship program, cycle through the program, they can pick up any of this work and continue to extend it. So it's just a wonderful way that we think we're going to be able to make a big difference here at PG&E and make that shift to the cloud. And with that, I'm going to hand it back over to Rolf.
Wonderful. Hey, thank you, John. This is excellent. Thanks for your insight of your work and the various programs you're running. And with that, let me just make sure that you understand where to find more information. Obviously, look on aws.amazon.com and the specific area for our industries, for power and utilities. You can create an account today and test some of those services we talked about, including the quick starts I mentioned. And obviously, there's always ways to find and contact somebody at AWS directly. But I would like to make sure we have some time for some Q&A. And with that, I would like to hand it over back to Rod.
Thank you, Rolf, and thank you, John, for a great presentation and how this transformation to the cloud can help utilities. It is now time to move on to the question and answer portion of the presentation. If you haven't already done so, please enter your questions by clicking on the Q&A widget and typing it in, and we'll respond to as many questions as time allows. So let's get started here. First question, and I guess I'll let you guys answer it, whoever wants to, but first question we have here is, how are you handling the utility-centric capital expense challenge?
This is John. I'll take that one. This is primarily for U.S. utilities, and the way the utility economics is driven is we can earn a rate of return on our capital investments, our assets that we put into the ground, and as a result of that, the capital investments are very much favored. When you make the shift to the cloud, you have it's OpEx, and so you're paying for just what you use, which is actually a really great thing. And what we're faced with is how do we treat these assets in such a way that allows us to both get a reasonable rate of return on what we've created and make sure we're reducing our price. We're working with our capital accounting teams here to understand the rules to make sure that we're following them. We're working very closely with our utility commission to find ways to treat these assets that we're creating in the cloud the same as we treat assets in our data centers. And so this is an ongoing journey. There is no silver bullet. In some cases, people are prepaying for their cloud utilization, and that turns out to be a good use, a good way to address some of that. So the other part of the equation is when you do the math on some of this stuff, it's viable to, it can be a fifth of the cost of buying and implementing these assets. It could be even less if you're doing serverless things. For example, that $30,000 use case versus the $25. So there's definitely viability when you look at the total cost of ownership of these solutions. It turns out in some cases you don't need to worry about capital or expense. And Ralph, you had mentioned something about working, putting a team together to work on this from Amazon. Is that correct?
So we obviously have internally also teams to work on policy. What I think is really interesting here is our cloud economics kind of team. So who could sit down and understand what John talked about in terms of TCO calculations, other forms of expenditure. So it's more like an advice, obviously, because it depends on your accounting methodologies, but there's definitely work done from various aspects from a regulatory perspective for us to provide our view and insights into this topic. So we're well aware of the challenge there. And by the way, it's not just the U.S. challenge. We hear it also in Europe, and it comes from often different directions. So it's very much on top of mind. Rod,
very good. Yes, I'll go ahead and start there. Thank you, Rolf, and thank you, John. Second question here revolves around what are your concerns around security?
Yeah, this is a big one. This is one of our number one things. It's right up there with safety in terms of the things that we're concerned about. We're critical infrastructure, so I mean, you take it for granted that when you flip a switch, the light comes on. When you plug in, it comes on. So we recognize and recognize that responsibility to society as a whole, and so being secure is very much a key component to this. A couple of things that I consider here. You heard me talk earlier about we're not going to move any of our grid operation systems to the cloud anytime soon. That may change over time, but right now we're definitely not going to be doing that. We also recognize that Amazon and the cloud providers, they invest more in security than we could ever think about. And they're doing that on a consistent and constant basis. They have entire teams that are set up to really drive home the securing of things. Now, that doesn't advocate our own responsibility to make sure we're operating our systems in a secure way, that we're putting in penetration testing into our development processes, that we're adhering to the compliance and regulation requirements. So having said all of that, so far we are finding the needs of the utility, the common needs of the utility, are very easily met by Amazon when it comes to security. And one of the big things that has happened is, what about, in the U.S. in particular, there's a governing body called NERC, and it has to do with how you operate your grid assets, your big grid assets. And we are very much thinking about how to do that. We haven't solved it, and I know this is something that Rolf and your team have been thinking about as well.
Yeah, on every level in every industry, we have dedicated compliance teams, which are working closely with our customers to address NERC SIP topics and provide advice on the methodologies and the processes to apply and be successful. And as the example showed in the Talon Energy, that's obviously as needed the possibility to host your data on a gov cloud, so the government cloud, with even additional security layers if required. Rod,
very good, guys. Thank you for that answer here. And I have another question here. What won't migrate to the cloud?
I've mentioned it a number of times. So the systems that are controlling the grid's assets, those won't move anytime soon. It's interesting because when we talk to people, it's like, well, if you've got an internet-facing presence, wouldn't that be a great thing to move to the cloud early, because you've got all this scale, you got 10 million customers or whatever, and you're having to maintain all this infrastructure. Well, it turns out that that's not going to go early. That's going to go later, mostly because you have to have a whole bunch of controls in place to let that happen. And we're going to work our way up to that. So I was working with the Amazon teams and some of our partners, and that popped up, and I kind of stepped back and went, well, that actually makes sense. And so that's an interesting development that's going to happen. But a lot of our just enterprise systems, we're looking at how do we move our CCNB. That's our internal customer application. How are we going to move our SAP environment to the cloud? How are we going to move our geospatial information system to the cloud? We know that all of these systems can be met with the power of the cloud, and there isn't anything we're not at bigger scale or have harder requirements to make those migrations. So we know that we can do a lot with it.
Yeah.
Well, thank you. And unfortunately, that's about all the time we have. Appreciate the questions. And on behalf of Power Grid International Magazine, as well as Pentwell, I want to thank today's presenters, Rolf Gibbles, who is Head of Worldwide Business Development for Amazon Web Services, and John Nichols, who is Director of Enterprise Architecture for Pacific Gas and Electric, for the great presentation today. I would also like to thank Amazon Web Services for sponsoring today's presentation, Innovation with Energy and Utilities at AWS. This presentation will be archived within 24 hours and can be accessed from the homepage at power-grid.com. A reminder email message for the archive will be sent to all of you who are registered. It will include a direct link to the archived webcast, so please feel free to share the link with your coworkers and peers. I want to thank all of you for joining us today. I know you're all very busy, and we appreciate you making the time for this presentation. I look forward to sharing future webcasts with you. I'm Rod Walton for Power Grid International Magazine, and have a great day, everyone.